Hey guys, you can now support this show and make your life 50% better by going to patreon.com/The System Is Down and signing up for the Downers Club, where you're going to get access to a plethora of wild, crazy, and often offensive bonus audio and video episodes of the show on a weekly basis. For more information, just go to patreon.com/The System Is Down. Today's episode is sponsored by the 29 Toes podcast. If at any point during this episode you find yourself a little too uncomfortable and triggered, you can head over to 29toes.com and kind of decompress your brain a little bit, where they're just having casual, laid-back, fun, funny conversations about things that are going on in their lives, in the world, things in media and entertainment, all that fun stuff. So check them out at 29toes.com or wherever podcasts are sold. The following is a Goulash Media production. goulashmedia.net.
Welcome to the System Is Down.
Well, ode to joy and hallelujah, Downers. Welcome to a new year. Brand new year together, 2019, and that means a brand new batch of uncomfortable content for you guys and your greedy little ears. It's a beautiful thing, and it's going to be fun. It's going to be fun. If you're new, welcome to the show. This is the place where we have all the conversations about things that trigger most people. This is the place where you come if you're offended by people who are offended by things. All the anti-PC things, all the things that are typically out of bound, that's what we talk about here, and we do so in a very civil manner, in a very logical, just humble, discussionary manner. Things like conspiracies, politics, and religion. So, if you're new, welcome to the show. Go find the person who invited you. Give them a big #MeToo, slap on the rear, and a kiss on the mouth from you and from me, because I really appreciate you being here, and you're going to appreciate being here as well. And you know how I know that? Because today's episode is great. It just is. It's not even a matter of opinion anymore. Today's episode is my conversation with Harvard University professor Dr. Avi Loeb. You may or may not know anything about Oumuamua, which is the giant cigar-shaped space object that seems to have floated into our galaxy from interstellar space, the first thing that we've picked up on our radars. Avi was such a great guy to speak to because he has completely different thought processes than I do. As you know, a lot of the things on this show go kind of against some of the scientific norms, but it's great to meet somebody who is way smarter than I am in that area, but also is extremely humble and really down to earth. So it was a great conversation. I loved talking to him, and we did a bonus hour as well that you can get in the Downers Club. Stick around. I'll tell you how you can get all that afterwards, but just know I did bring up Flat Earth, and I did bring up climate change, and I did bring up the moon landing to Dr. Loeb. So if you want that, stick around after the show. Find out how you can join the Downers Club and support the show. But until then, enjoy and welcome, and let's do this. 2019 together. Let's kick it off with a big bang, a good scientific big bang. Dr. Avi Loeb. Let's get weird. Well, ladies and gentlemen, honestly, I don't even think I'm qualified to read these qualifications, but my guest today is theoretical physicist, junior professor of science at Harvard University, founder of Harvard's Black Hole Initiative, serving on the advisory committee for the Breakthrough Starshot Initiative, selected on Times Magazine's 25 most influential people in space, author of over 700 papers, an all-around fascinating individual, Dr. Abraham Avi Loeb. Dr. Loeb, how are you today, sir?
Very well, thank you.
How did I do? Did I spew that all out efficiently for you?
The labels are much less important to me. I really care about the substance, and
sure.
Usually, by the way, I speak with people irrespective of their labels,
Mm-hmm.
and I enjoy speaking to lay people much more than my colleagues quite often. When someone comes to fix the plumbing at my home, I often spend an hour or two talking either about science or their personal life, and because I feel that what matters the most is the a person's sincerity, and if a person is not swayed by his or her ego, that's most important. And unfortunately, a lot of people, have other motivations for speaking with you.
Absolutely. Yeah, and I got to say, I mean, if you enjoy talking to the layperson more than usual, then you're going to have a great time today, because I'm as simple as they come, and I accept that. I accept that my place in this show is to unabashedly kind of bridge the cavern between smarter people and the layperson. So,
well, I'm a layperson myself. I
Sure.
grew up on a farm, and I only explain things that I understand. Let's put it this way.
Sure, yeah. And actually, I do like to start out all of my interviews, whether it necessarily weighs into what we're going to talk about or not. I like to get a little bit of background on you, kind of your upbringing, that type of thing, just to kind of see where you come from.
Well, I was, as I mentioned, born on a farm. I used to collect eggs every afternoon in Israel. I was never worried about being tenured at a university, because I always had this plan B, that I could go back to the farm and work there. And, it has its own pleasure of seeing nature very often, rather than dealing with people. And I sometimes miss it. And then at a young age, I was mostly interested in philosophy, the fundamental questions. But in Israel, there is an obligatory service in the military at age 18, and I preferred to study and do research than run in the fields. So I was recruited to a special program that allows 20 to 30 people every year to study and then do work that is useful for the defense of the country, research related. And so I finished my first degree in physics and mathematics at age 21, and then I finished my PhD at age 24 in that program. And I worked on a project that was funded by the US for the SDI at the time when Ronald Reagan was president. Mm-hmm. There was the Strategic Defense Initiative. And we were the first project funded by the US internationally within that program. And that allowed me to come to the US and visit places. And in one of the visits, I went to the Institute for Advanced Study at Princeton and met some people there, and was offered a postdoctoral position after I finished my military service. And that's where I was for 5 years at Princeton. And after that, I thought of going back to philosophy, my true love. But then I had the opportunity to come to Harvard as a junior faculty. They offered the position first to someone else that decided not to take it, because the chance of getting tenured at Harvard are slim. And so I accepted it because I had plan B. I can always go back to the farm, and I was not intimidated by this. Mm-hmm. And then 3 years later, I was tenured here at Harvard. And now I'm the chair of the astronomy department and the director of 2 centers here at Harvard. But my upbringing, the fact that it was not conventional, taught me some important lessons, that I should accept people irrespective of where they come from, and pay most attention to the way people grow rather than where they started. There are many people that have unfortunate circumstances. They come from places where they don't get a good education, or they are minorities in terms of ethnic origin, sure, or they have. And so I accept people of all backgrounds and try to help them fulfill themselves. And that's one of the missions of, the kind of environment that I created around me here, that we encourage people of all backgrounds. And I also find it important to communicate to the public, because not only that we are paid for what we are doing, part of it is paid by taxpayers' money, and we owe giving back in terms of what we learn, right, but also because I think, first of all, that the public has some important insights, and the public needs to understand how science is done. So just to give you an example, in the context of what we will discuss today, some scientists argue, let's not talk about it to the public. Let's keep it among ourselves until we have a definite answer, until right, we know for sure, based on a lot of data, what the truth is. And I say, no, that's not a healthy situation. You don't want to close yourself in a room and then come out and announce announce the result only when you know for sure what it is, because the only way for the public to have confidence in what scientists are saying is to see that a lot of the process involves uncertainty. We are not sure about, we don't have enough evidence sometimes. And under these circumstances, we are unsure. We can make mistakes, you know.
We're
and,
humans.
You know, even Albert Einstein made a lot of mistakes. Late in his life, he thought that black holes don't exist, that gravitational waves don't exist. Both of these things were discovered 2 years ago, and the Nobel Prize was given to it last year, discovery of gravitational waves from black hole collisions at the edge of the universe, the LIGO Observatory. So he was proven wrong time and time again. And also about quantum mechanics, he made some statements that are incorrect. And it's part of the process of science that you have to take some risks. You don't have full information, and you make mistakes sometimes. And we should not hide it from the public. When the public understands that science is a process, you know, it's a learning process. It's just like continuing your childhood curiosity. You know, as a child, you are often wondering about the world around you. You're not sure, you're asking questions, you're making mistakes. Some of these questions end up not making too much sense. And we lose that innocence when we become adults. You know, people are afraid because they worry about their image, and they are not willing to take risks, and because their image may be damaged. They're not willing to make mistakes, because then people will not take them seriously. And that's really a bad attitude if you want to allow yourself to make discoveries, to find something new that nobody knew before. The only way to do that is by taking some risk when the evidence is not at all clear, you know, having some uncertainty and you know, potentially making mistakes, but you are learning in the process, and it's a learning experience. And that's the beauty of being a scientist, that you can maintain your childhood curiosity without worrying. Especially after you get tenured as a professor, you have job security. And I just don't understand some of my colleagues that after getting tenured, they become even more conservative. They're even more worried about their image and their ego and so forth. And they don't fulfill the promise of actually being open-minded and considering all possibilities. You know, Sherlock Holmes, it's just like being a detective. And Sherlock Holmes is the ultimate detective. And he said that, you know, when you consider a crime scene, and once you excluded all other possibilities, whatever remains, however improbable it is, must be the truth. And so he was completely open-minded because of experience. He realized that, you know, you can't solve a crime if you have a prejudice, you know. And for the same reason, you can't do good science if you have a prejudice. If you think you know the truth before you actually look for the evidence, you know, you will just not find it, because sometimes you're wrong.
Right. Yeah, extremely well put. And I mean, we could do a whole episode just on that alone. I applaud you for your open-mindedness, and I feel like, well, I told you when I contacted you that we talk about like politics, conspiracies, religion, that type of thing. And a lot of the conspiracy-minded people, they seem to distrust the science community because of that lack of transparency, because they have proven time and time again that they are hiding certain things. And even if it's just hiding the fact that they're humans that don't necessarily know every single thing, it comes across in a bad way for the community.
This is exactly the point. So that's my answer to those people that say, let's first figure out the answer and then give it to the public. My point is the public needs to see that it's a human activity, that, you know, that scientists are human, that they are, most of the time they are uncertain because there is not enough evidence. And anyone that would see limited evidence would be uncertain and could make mistakes.
Sure.
And when the public sees that, the public gets a better trust at the scientific process. It doesn't look sterile. You know, it looks like it's part of something that you would do naturally if you want to figure out something. And I think being credible is extremely important for science. It shouldn't be regarded as an occupation of the elite, for example. It should be regarded as, you know, just as a child asks questions, we ask questions, we try to figure out what's what's the truth. And once we have enough evidence, once things are obvious, then we admit that we know what the answer is. But before that, we just don't know. And sometimes we make mistakes. And that's human. There is nothing bad about it.
Absolutely.
And it's a learning experience. And so all of these principles apply to the case of Oumuamua that we will discuss. And that is one of the reasons that I thought it's important to use it as a platform to explain the scientific process. That most of the time we are uncertain because we don't have enough evidence. And anyone that says otherwise is portraying an image which is untrue about science. And I can give you a lot of examples. Just to give you one example, we see stars moving inside galaxies like the Milky Way galaxy, stars like the sun, and they move much faster than we expect. Okay, and it's what we expect is based on the stars themselves. Just seeing those stars, we know how much mass there is out there, and it seems like there is much more mass than we can see. Something else is pulling them through the gravitational force. And we don't know what it is. So we call it dark matter. And dark matter is simply an idea that there is additional matter to the matter that we see, the visible matter. There is some other stuff out there that we can't see. Right. And that's what binds galaxies much more than the ordinary matter. And we haven't detected the dark matter. We just believe that it's there based on all the evidence but it's still it has to be proven. We have to find what matter are we talking about? What kind of particle is it? Right. We haven't yet detected that particle. So at the moment, it's proposal, a theory that has to be confirmed. And, it's in the mainstream of astrophysics. And if you ask any astrophysicist, they will tell you that they think that dark matter exists. Now, it doesn't prove the existence. It's just that it's part of the mainstream. And it's this situation of uncertainty where we still don't know what it is that is the longest phase that you face as a scientist. Most of the time you are uncertain because you just don't have enough. Once you have enough evidence, then it goes into a textbook, and then it's a closed chapter. Then it's not exciting anymore because we know already the answer. So I mean, the exciting part of doing science is actually that uncertainty, the fact that we don't know what the explanation is. We're trying to figure it out, sort of like a detective story. Right. And the situation with Oumuamua, as far as I'm concerned, is the same. And most of the time, you discover new things when you see anomalies, things that just don't fit, things that the conventional explanations cannot explain. And under these circumstances, you start to think about other explanations, and that's what brings you to new realizations, new ideas about what might be behind what you see. And that's the most interesting situation that a scientist can have, a situation where the conventional explanations just cannot explain what you see.
Absolutely. Yeah, beautifully put. And you've brought up Oumuamua a couple times. That is really what we're here to discuss. You co-authored a paper that has proven to be a bit controversial amongst your peers, which, I mean, that's what we're talking about here. So give kind of a brief rundown of what you proposed in this paper. And I know a lot of the listeners actually aren't super familiar with what even Oumuamua is, so maybe give a brief background on that as well.
Sure. So Oumuamua is the very first interstellar visitor that we discovered in the solar system. And by that, I mean an object that was born outside the solar system that we discovered close to the Earth, passing by. So it came from outside the solar system and it will go out. It would leave us. And it's sort of like having a guest for dinner. And that was unexpected. And suddenly you realize that this guest comes from another country. And then you realize that you can learn about the culture in that country without spending the money on paying an airline ticket to go there. You can just look at this guest. But by the time you realize the guest is really special and unusual, the guest already is out the door into the dark street. And that's the unfortunate fact that we haven't collected all the information that we could have if we knew everything about Oumuamua to start with. because
And
it was
you don't have the technology to chase down that guest in the dark either. It's they're gone.
Right now, yes, it's moving faster than chemical rockets that we have developed over the years. So, but it will take it a while. It will take it thousands of years to leave the solar system. So if in principle within the next decade, we develop the space technologies that allow us to move faster, potentially we can chase it and take a closer look.
Sure.
Otherwise, there is a much cheaper approach, which is to wait for the next guest. And the situation is similar to my favorite activity when I go on vacation to a place where there is a beach. I go with my girls, my daughters, to look at seashells that were swept ashore. And each seashell looks different than another, different origins. And every now and then, you find an object of an artificial origin, such as a plastic bottle or a regular,
Sure.
bottle. And of course, you can get a message in a bottle. And so every object that comes to the solar system from outside should be studied, because we never know. Maybe it's natural in origin, but it could also be artificial in origin. And therefore, the detection of Oumuamua by itself opens a new window into figuring out what happens elsewhere without going there. So we will just examine objects that come to us and see if any of them looks like a message in a bottle. Because we ourselves sent out the Voyager 1 and Voyager 2 that are already outside the region where the solar wind interacts, meets the interstellar medium. So that's sort of one edge of the solar system. It's not completely out of the solar system yet, but we are sending our bottles out. Voyager 1 and Voyager 2 carry technology from 50 years ago, and presumably in the next century we'll send even more. And since we are sending out these things, if there is another civilization out there, they might send things in our direction. And I should say that, the topic of extraterrestrial civilizations, that idea is considered outside the mainstream right now.
Yeah.
There was no federal funding for it since 1993. And I find that very strange, because in my mind, it's not really a speculation, because it's based on two facts. One fact that we exist, we know that,
right,
as a civilization. And the second fact is that we now know that about a quarter of all the stars in the Milky Way galaxy have a planet of the size of the Earth that is in the habitable zone. In other words, it has a surface temperature that allows liquid water to exist and the chemistry of life as we know it. So it means that you roll the dice so many times, a quarter of all the stars, we are talking about, tens of billions of stars. You roll the dice tens of billions of times. What's the chance that we will be the only ones? I think it's very small. I think out of modesty, just admitting that we are not special, if you start from that point of view, that from a modest point of view,
sure,
then you must accept the possibility that there is another civilization or many other civilizations out there, and there might be traffic, there might be space debris that is sent out by these civilizations. So to me, it's not a speculative idea. I think it's a reasonable idea that should be part of the mainstream to search for signals or artifacts from such civilizations that are not ours. And if we find anything, we will realize that we are not the smartest kid in the block. Mm-hmm. We might see that there are technologies far more advanced than ours. And that will keep our sense of humility. So right now, anyone that claims that it's a speculative idea to consider extraterrestrial civilizations, I think is showing some arrogance, because that person thinks that we are very special, that nothing else resembles us. Mm-hmm. And of course, most of these civilizations may not be around anymore, might be dead, because sure, if you look at our civilization, the moment we started developing advanced technologies, we also developed the means for our own destruction. We have nuclear weapons, right, we have the ability to change the climate on Earth, and so you can imagine that technological civilizations are short-lived, that they have a finite lifetime, which is relatively short, hundreds of years, thousands of years, and that's it. And that's why at any given time, there might not be many alive at the same time.
Right.
But on the other hand, even if that's the case, whatever relics they sent out to space or whatever artifacts they produced should be out there. And so, we can search for dead civilizations. We can search for, I call it space archaeology. Basically, the same thing that we do here on Earth. We are digging into the ground to look for ancient cultures that existed. That's called archaeology. You can do the same thing in space. You can dig into space and look for signals from or artifacts that belonged to civilizations that are not alive anymore. And it's quite possible that this would be the most typical situation because they have a short lifetime and all we can find is space debris. And so that's why we should be open-minded and we should search any object that comes our way into the solar system. And so that's what Oumuamua really opened up. It opened up this interesting frontier. And I should say it was strange on several counts. So let me just mention a few properties that are really weird about this. And every property by itself is weird, but when you put all of them together, it looks like a really weird guest that we had for dinner. Okay, so one property that was immediately clear, even before that, we didn't expect Oumuamua to come because I actually wrote a paper about a decade ago with some collaborators forecasting how many such objects should exist based on the solar system. So assuming that, all other stars are similar to the sun and they have planetary systems similar to the solar system, they eject rocks all the time. And we estimated how many rocks should be in outer space and what's the chance that one of them would cross us and we would see it. And we expected somewhere between 100 to 100 million fewer rocks than necessary to explain the detection of Oumuamua. So we didn't expect it. We expected a much smaller population of rocks, interstellar rocks. But okay, let's accept that, maybe we underestimated. Maybe there are other nurseries of such objects that produce them at much larger abundance. The object itself was strange because it changed. It was spinning around over 8 hours.
Spinning like end over end?
Actually tumbling. So it was not spinning. And the reason we know that is because its brightness changed.
Sure.
And the brightness of such an object, a piece of rock or anything, is due to reflected sunlight. So sunlight is coming on its surface and it gets reflected towards us. And as it spins around, you see different amount of light because you see a different area of the object or surface projected on the sky. Okay, so that's the idea.
Sure.
So the brightness of this object changed by a factor of 10 times between the faint phase and the bright phase. And if the object has a constant reflectivity, if it reflects the same in all directions, then it means that it is 10 times longer than it is wide, at least projected on the sky. But in fact, even for a very thin object, it's very unlikely that it will be exactly edge-on relative to us. So I would say that the shape of the object is even more extreme than 1 to 10.
Okay.
And all the objects that we have seen that were born in the solar system, such as asteroids or comets, at most had a brightness variation of order 1 to 3. Okay, so this one was extreme in that sense, 1 to 10. But so the first peculiar fact is the object must be extreme. And some people analyzed the tumbling motion of this object and concluded that if it was kicked around a lot, then it's most likely to be pancake shaped. If it's excited, very excited by all kinds of kicks. But if it's
or saucer shaped, as some might say.
Yeah, or if it's not excited much, if it's at the minimum excitation that you can have it, then the tumbling motion is indicative of a cigar-shaped object.
Sure.
And what you find in the artist illustrations that are most common on the internet is cigar-shaped for some reason. But actually, in my mind, this object was kicked around probably quite a lot. So actually, a pancake shape is more likely, I would say. Imagine a
real
pancake
quick
shaped
to
thing.
cut in there. You brought up the artist renditions. Have you seen, like, is there footage out there or the pictures? I don't really know how this stuff works as far as
we don't have any. We don't have any image. That's the problem. If we had an image, we would be able to tell what it is, whether it's artificial or natural.
Sure.
That's the problem, because we became alerted to this object relatively late, when it already passed near us and started to move away from us. And it was discovered on the 19th of October 2017, and within a couple of months, it became too faint for us to continue observing it, and we just didn't catch it in time to get more information about it. It would have been amazing if we had a photograph of it, so the hope is perhaps in the future to see something similar to it, another member of its population, and within 3 years there will be a new telescope called the Large Synoptic Survey Telescope, LSST, which will start operating in about 3 years, and it will be much more sensitive than the Pan-STARRS telescope that was used to discover Oumuamua. Pan-STARRS telescope is in Hawaii, on Mount Haleakala. I actually visited that place a couple of years ago, and that's why this object was named Oumuamua, which has a meaning in Hawaiian, in the language. It means a scout, a visitor from a distant location that comes to see us. So hopefully there would be, with the LSST, we will be able to find many more. And if LSST starts operating and then within a year or two doesn't see anything, then we will know that there is another unusual feature about Oumuamua, that it was special. It was not part of a population of objects on random trajectories. But let me add a few more strange facts about it. It looks like this object has no cometary tail. Usually a tail behind a comet is, you get it from the heating of the surface of the comet by the sunlight that warms up the surface, and then the ices on the surface evaporate, and you end up with dust particles reflecting sunlight in the tail of the comet. That's what gives it the appearance of a tail. There is nothing like it. We don't see any tail around this object. So people thought, it's not a comet. But nevertheless, what happens is that these objects seem to deviate from the orbit that you expect based on just the sun's gravity. So there is an orbit that you can calculate for an object that is moving under the influence of gravity by the sun, and this object seems to deviate from it. And the only other way that people considered in the past for such a deviation is cometary outgassing, where there is evaporation from the surface of the comet, but we don't see anything like it. I should say that the deviation is small. It's at the level of 0.1%, but it's very significant because you need about 10% of the object to evaporate. It needs to lose about 1/10 of its mass in order to give it enough push that would account for the deviation from the orbit that we see. And so we don't see a cometary tail. Moreover, the Spitzer Space Telescope looked at this object and didn't detect any carbon monoxide, carbon dioxide, all kinds of gases that usually are associated with outgassing from a comet.
Right.
And it put very tight limits on that. So there is no evidence for that. And also, when comets evaporate, they change their tumbling motion, they change their spin, because the force that acts as a result of the outgassing is not even across their surface. So one end is pushed a little more than the other end, and so they change the spin period, for example. And this object was pretty stable. The spin period was the same. It didn't change with time. And that's another argument that there was probably no outgassing from this object. So on all three counts, we don't see cometary tail. We don't see any gases, carbon-based gases around it. And its spin period didn't change. On all three counts, it looks like it's not a comet. Mm-hmm. And it has a shape that is quite different than an asteroid that we have seen before. And moreover, the Spitzer Space Telescope tried to look for thermal emission, heat from it coming off it, and didn't detect any heat. And that implies that the object is relatively small, because we know roughly its temperature, the temperature that its surface was heated to, because we know the trajectory, so we know how close to the sun it went, so we can calculate how hot it became, but we don't see any heat from it, and therefore it must be small. And the limit is of order 100 meters to 200 meters. So it needs to be smaller than that size. But we know how much sunlight was reflected off it. And so given the size limit, we can say that it's very shiny. It was smaller than 100 meters, but more than 10 to 20% reflective. It reflected more than a tenth of the sunlight that was falling on its surface. And that's at the upper end of all the objects that we have seen in the solar system. So it's about 10 times more shiny than a typical comet or a typical asteroid. So it is a shiny, small object that is probably pancake-shaped, mm-hmm. with at least 10 times larger size than its width, or more than that. We don't know. And so these were the kind of strange facts. And then there is one last strange fact, and that's that the origin of the object is from a very special frame of reference. It's the frame of reference that you get to when you average over the motion of all the stars in the vicinity of the sun. Mm-hmm. So the sun mm-hmm. and stars near it are moving relative to each other. They have some random motion, but you can average over these motions. It's sort of like going to a crowd of people and seeing the people moving around, but you can average over the motion of the people, and the crowd as a whole is in one location, on a single street, sure. You see it. People are moving relative to each other, but the crowd is at rest, Mm-hmm. And it turns out that Oumuamua is at rest in the frame that you get to when you average over the motions of all the stars in the vicinity of the sun, which this is called the local standard of rest.
Right.
And only one star in 500 is in that frame. So that's very strange, because if it came from a star, it should have inherited the motion of that star. And, it doesn't seem to. It seems to be at rest in this frame. It's just strange. And one way to think of it is sort of like a buoy sitting on the surface of the ocean,
right?
And at rest, and then the solar system, just like a ship, runs into it and kicks it. You may ask, okay, why would you have these buoys sitting on the surface at rest? And one possibility is maybe there are signposts, road posts that are out there, and who knows? But the point of the matter is that Oumuamua was strange in that respect as well. It was in a special frame of reference, and the solar system just ran into it. And then the question still remains: what gave Oumuamua an extra push in addition to the force of gravity from the sun? What if it's not cometary outgassing, which is the usual force that is pushing on comets? If there is no cometary tail, there is nothing else to push. What else can push it? And the only thing that I could think of is sunlight itself. And in order for sunlight to push it when it reflects off it, the only way to do it is to make the object very thin. And we calculated in our paper with Shmuel Bialy, we calculated how thin it should be, mm-hmm. and we found that it should be less than a millimeter thick. So less than a small fraction, like less than 1/20th of an inch or so.
Yeah.
And
That's quite the opposite of what everybody's depicting with these cigar-shaped giant space rocks.
right. Although it's consistent with a pancake
Sure.
shape, and it's consistent with it being much longer than it is wide, and it's consistent with it being a good reflector, a shiny object, because the only thing that one can imagine in this context is a light sail, a sail that is pushed by light, which is a technology that we are currently developing here on Earth. So the idea is very similar to a sailboat. On a sailboat, you have a sail which is pushed by wind. And the wind is just air that is reflected off the surface of this sail. And when the wind is reflected, it gives it a push. And the same thing applies to light. When light reflects off a surface, like a mirror, it gives it a little push. And usually the push is small, but if you build a big enough sail, even light can push it to a relatively high speed. Yeah. And so the idea was maybe Oumuamua is just a light sail that was pushed by the sunlight, by the light from the sun. And for that to happen, you needed to be of the size of several tens of meters, consistent with the constraint from the Spitzer Space Telescope. It should be shiny, again, consistent with the Spitzer Space Telescope data that, by the way, came after our paper. This data was reported after our paper, so we didn't know about it, all these details. And then, so it's several tens of meters in size, very shiny, and that less than a millimeter thick, and that would explain the extra push. And we just put it out there, and I was frankly quite surprised to see the interest and the reaction from the public. We didn't intend to have a press release. This was not a publicity stunt. It was just a scientific paper that was accepted for publication, by the way, after 3 days, which is a record I've never seen. It was immediately accepted for publication in one of the most prestigious journals that we have in astrophysics, called the Astrophysical Journal Letters. And it went through peer review, and it was accepted for publication. And we didn't have a press release. The public got very interested. And I basically tried to answer questions that I'm being asked, just like in this interview. And, whoever has issues with that, that's part of the scientific process. We saw an anomaly, we saw a number of anomalies. I pointed out about 6 of them, that this object showed. This is the only explanation I could think of. So we wrote a paper about it. We put it out. If anyone has a better explanation, they should write a paper.
Right.
And we can.
So basically, your statement is just this thing we can't explain might have an explanation. Like nobody else is putting anything out there. Why aren't we looking at this?
Exactly, and one should be open-minded. And the importance of putting out a possibility of this type on the table, even if some people don't like it. And by the way, I should say, some people, reporters would ask me, what is your gut feeling? What do you think? Is this really artificial? Is your gut feeling that it's artificial? And I didn't want to answer this question because gut feeling is very often misleading, because there are lots of examples in the history of science where people had the wrong gut feeling. And the reason for that is because it's based on past experience. Gut feeling is basically using what you experienced in the past to try and forecast the future. And if you expect the future to be the same as the past, then it's a very good guide. Yeah. But if you want to allow yourself to find something new, then it's a very bad guide, because it limits your horizons. You basically, you will never discover anything new because you always assume.
Makes science really boring.
Yeah, and yeah, exactly. And just to give you examples from the history of science, before Galileo Galilei, who established the modern methodology of science, before him, people thought that heavy things fall faster than light things under the force of gravity. And he wanted to test it. So in Pisa, there is this famous story about him going to the Tower of Pisa and dropping things of different weights and noticing that they fall at the same rate. Mm-hmm. And he discovered that irrespective of how heavy something is, it falls exactly the same way under the influence of gravity. Mm-hmm. And that ended up, this insight, which is completely against our gut feeling, ended up being the foundation for Einstein's theory of gravity. It's called the equivalence principle, that all objects fall the same way under the influence of gravity, irrespective of what they are made of, how much they weigh. And that's what led Einstein to decide that perhaps gravity is not a force, perhaps it's just a property of space and time, curvature of space and time, because all objects respond to space and time the same way. Right. And that's what gave Einstein the insight. This fact that Galileo did not believe the gut feeling that people had at the time, hundreds of years before Einstein. So just to show you, that's one example. Then Einstein himself resisted the idea when quantum mechanics was discovered experimentally. It basically implied that you can have action at a distance. And Einstein thought that it's very spooky. He called it spooky action at a distance. And he didn't believe it. He thought that we are misinterpreting quantum mechanics. Yeah. And he wrote papers about why it should be wrong, this interpretation. It turned out that he was wrong. Experiments were done long after he passed away and demonstrated that quantum mechanics, the original interpretation, was correct. Mm-hmm. These are called the Bell test experiments. And Einstein was simply wrong, and his gut feeling was wrong. And you know, the reason that he was wrong is because he was basing his gut feeling, his intuition, on his past experience. And quantum mechanics was something completely new. It was different than classical physics before. And as a result, Einstein made the wrong assertion. And so that's why gut feelings are not good guide when you deal with science. You should not have a prejudice. You should not have an agenda. You should not have, you should be open-minded. And when people say, oh, of course it's not artificial, it makes no sense. If they don't base it on evidence, then it means nothing. It just means that your prejudice is to say that the chance of this being right is zero. So you, ahead of time, it's a self-fulfilling prophecy. When you say the chance for something to be true is zero, then you never check if it's indeed true or not, and then you think that you're right. But by the way, who cares what you think? Because reality is what it is. This object is whatever it is, irrespective of what people write in Twitter.
Absolutely.
People may agree on Twitter and say, oh, this is not artificial for sure, and agree on that, just the way that people agreed that heavy things fall faster than light things in the days of Galileo. But it doesn't matter. Reality is what it is. This object is what it is. And the fact that we have the wrong idea is irrelevant. So, science is not about agreeing about something based on prejudice. It's about trying to get as much evidence as possible and finding what nature tells us. It's a dialogue with nature. It's a dialogue. It's not a monologue. A lot of people think about it being a monologue where, we sit in a room and we think about it and we come up to the correct conclusion and that's it. And then we don't need experiments. Let's just think about what the truth is. Mm-hmm. I have a problem with that because we should be humble. We should be modest. Right. It's a learning experience. We have a
Some
dialogue.
Some things just are no matter how you feel about it.
Exactly. And so maybe this is an artificial object. Mm-hmm. We should be open-minded. Why resist the idea that other civilizations may have sent some space debris?
Sure.
This has nothing to do with unidentified flying objects. That's a completely. We are talking here about a very specific object for which we have data, scientific data, that we need to explain. And the data shows anomalies that we cannot explain with a cometary tail, that we cannot explain in the standard way. It doesn't look anything like the objects we have seen in the solar system before. It's a much greater abundance than we expected. And it seems to be shiny and small and seems to deviate from an orbit that you expect. So let's consider all possibilities. And why should we have a prejudice about it? I mean, that to me, and I find that really strange. Now, I should say that, there are colleagues that I respect, some very distinguished scientists. And when I spoke to them, they were very open-minded. They said, this is a very strange object. Mm-hmm. They would admit it. The people that would resist it are usually scientists that are not of the highest caliber. These are scientists that I don't respect much, that would say, oh, no, for sure it's not.
Sure.
Because they base it on prejudice. And so, any highly qualified scientist would tell you that, A lot of the time we are uncertain. That's most of the time, actually.
Right.
We don't have enough evidence, and we should put conjectures out there. And some conjectures are accepted as part of the mainstream, others are not. But that's no indication as to the validity as long as we don't have the evidence. Once we have the evidence, we select the one that looks most plausible. For example, in particle physics, right now, people are talking about extra dimensions as being a mainstream idea. We don't live just in 3 dimensions plus time. There are some extra dimensions. And everyone thinks, oh, that's a very plausible idea. That's mainstream.
Right.
But we haven't found any evidence for extra dimensions. It's completely speculative, much more speculative than thinking about an extraterrestrial civilization.
Right.
Because that's based on one civilization we know about and the fact that other planets have conditions similar to the Earth. And so to me, it's sometimes puzzling why some ideas become part of the mainstream and some not, even though those ideas that become part of the mainstream are sometimes more speculative and more imaginative. And it has to do with the sociology of science, the fact that, when a group of people, a big enough group of people agrees that something is worth working on, then they might work on it, even if it's not worth working on, even if it doesn't describe reality. But eventually, the good news is that eventually the goal of science is to collect enough evidence, enough data, that we can sort things out, that we can figure out what was a waste of time and what is really exciting. But until then, we should be open-minded.
Yeah, absolutely. Now, with some of this pushback that you've received for putting this paper out, like what are their concerns? Like, what are people saying? What are they? What is the pushback exactly that they're giving you to even floating this idea out there?
Not much, actually. Nobody brought up. I mean, the only argument that I noticed was to say that the likelihood of seeing something artificial must be very small, and that there are things that we know about that we cannot explain, but we know that they originate from conventional explanations. So sometimes we see a mystery, and we can't really explain it, but we know that it's nothing, there must be a reason that explains it. Well, that's not the way science works because, for example, in the context of dark matter, we see the motion of stars, we see the motion of ordinary matter. We cannot explain it with ordinary matter, with conventional explanations. Therefore, we come up with a hypothesis, something new like dark matter. So, there must be something to explain it. And if all conventional explanations fail, then there should be something new, some either new physics or new ingredient that you haven't considered. And that's the way that the scientific process goes by. It's nothing unusual. And this object exhibits anomalies. If we can explain all of the anomalies in the standard way, that would be fine. If we cannot, then let's consider all other possibilities. And I'm not saying that it's artificial, and I'm just saying we need more evidence. I'm trying to motivate future observations. So the importance of this proposal is that when the next object comes around, I hope that my colleagues, all the astronomers, will use the very best facilities we have to get as much data as possible. And so just to give you an example, we wrote a paper just a few weeks ago with an undergraduate student here at Harvard. And we tried to ask the following question. So if there is a population of such objects that we now can calibrate based on the detection of Oumuamua, then some of them passed very close to Jupiter on their way into the solar system. And when an object passes close to Jupiter, within 10 times the size of Jupiter, it can give a small nudge, a small kick to Jupiter as a result of the interaction with Jupiter and lose some energy in that process. And as a result of that, it can get trapped by the solar system. So the way to think of it is that Jupiter and the Sun act as a fishing net. They can collect objects from interstellar space. And in a previous paper with my postdoc Manasvi Lingam, we predicted that at any given time there should be of order 6,000 such objects that were of the size of Oumuamua, that were trapped by Jupiter, the Jupiter Sun fishing net. They eventually they leave the system because they get kicked around by planets. So they have a lifetime of over 500,000 years within the solar system. But new ones come in, and at any given time you have 6,000 of them. And with this undergraduate student, what we try to do is calculate the orbits of these objects that are trapped. Maybe they are very unusual. Can we identify them based on their unusual orbits? And we found that indeed, some of them move on orbits that are completely perpendicular, for example, to the plane in which the planets orbit. So they have an orbit that is completely perpendicular to the orbit of planets. And that is very difficult to produce by objects that were born in the solar system. And so we basically predicted that there should be, hundreds of such objects that are unusual in their orbits, out of which tens of them would be discovered by LSST within a few years. And we looked at past surveys of objects in the solar system and found 4 of them to belong to this category of unusual orbits. We don't know if they are interstellar, but we see that their orbits are quite unusual. And if they are interstellar, they offer a very interesting possibility because they are trapped by the solar system. It's sort of like one of these guests that came for dinner that we didn't expect, that bumped into the wall instead of going out the door in our house and stays there. And there, so you can study this person more because it didn't leave the house. And so there are 4 such objects that we identify that one can study that are potentially interstellar, so one can design a mission to visit them. They are trapped in the solar system, so they are not leaving anytime soon. It will take them 500,000 years to leave the system. So we can design a mission to fly by them, get an image of them, or perhaps even land on them and scoop material to see whether they might have life on them. Because we also calculated that about every 100,000 years, an object like Oumuamua should collide with the Earth. So, if it carries life, there is the chance that life on Earth was brought from outside the solar system. And, we would like to know if there is life out there. And one way to find out is to examine all the interstellar objects to see if any of them carries life.
Right. Hey, Dan Smots here. I'm taking a second to interrupt myself talking to talk about myself because, I don't get paid a penny for the hours and hours that I put into creating this show for you guys in your greedy little ears, and I've got a family to feed. To make that happen, I run my own media business called Goulash Media. If you have a need in anything from video production to graphic design to audio production and beyond, you can get it all for a painfully fair price at Goulash Media. In video, I do weddings, music videos, commercials, pageants, plays, etc., etc., etc. For design, I do photo editing, album art, logos, branding, business cards, merchandise, you name it. For audio, I do engineering, production, editing, jingles, and, well, podcasts. So if you've got a media need of any kind, or if you'd just like to give a little something back and help keep my children fed, check out all the endless options at my website, goulashmedia.net. That's goulash, Goulash, media.net, where we cater to the little guy with the big vision. Okay. So before getting into the Oumuamua stuff, what were your thoughts on extraterrestrial life, and has that changed at all with these revelations?
So I was I approached this subject from a point of view of being modest. I call it cosmic modesty. I don't think that we are special. Whenever we thought that we were special, we were proven wrong. So we thought that we are at the center of the universe, that the sun moves around the Earth. Again, that was a gut feeling. We saw the sun moving in the sky, and so we said, probably the sun moves around the Earth, and that was our gut feeling. Right. Turns out that the Earth moves around the sun, and we are not at the center of the solar system. Turns out that the sun is not at the center of the galaxy. It's actually moving around the center of the galaxy, and the galaxy itself, the Milky Way, is moving in some random direction. So we are clearly not at the center stage of the universe, okay, in the physical universe. But some people prefer to believe maybe we're unique in terms of being biological creatures. There is only life on Earth. Maybe there is only one advanced civilization like our own. I don't think so. I think we are probably not special. What we see here on Earth probably happened and happens in many other places. And that's why I think we should search for it. I don't think we should assume anything. It's an exploration. We just explore the sky and try to figure out. And of course, if we find evidence for another civilization, then we could learn from it because we would see technologies that we haven't thought about. It would feel just like cheating in an exam where you see some very advanced technologies or science out there that gives answers to questions that we could not figure out yet. But it would be exciting and it would give us a perspective, a different perspective about our place. And perhaps, people will treat each other better because, suppose we find evidence for a dead civilization out there that went through a nuclear war and killed itself or destroyed its planet. Then it would teach us an important lesson to get our act together and avoid a similar fate.
Yeah.
Another thing is maybe we'll develop the technologies that allow us to leave the Earth and go into space, because we would realize, that there are lots of risks on Earth. And why should we put all our eggs in one basket? Let's spread our eggs, into spacecrafts that carry, they can carry robots and 3D printers such that, they can build whatever we want out of the raw materials that are being scooped by these robots. So if they go to another planet, we can create life there out of the raw materials using robots and 3D printers. We can, instead of us going on board, which is very risky because, humans are not designed for space. People contemplate the possibility of humans being on Mars. That's a very dangerous place to be on because of cosmic rays. 1 in 10 cells in our brain will get damaged within a few years of being on Mars unprotected. It's really much more comfortable to stay on Earth. And it's better to send technology out because we can design the technology to be resilient to all the risks out there. And so I think, given that we would probably send technology out, that other civilizations might have done the same. And that's why the most common signature of other civilization might be, space debris.
Sure.
And, once we send our own, and, I'm involved, for example, in the Breakthrough Starshot Initiative, which is a project to send a probe to the nearest star, Proxima Centauri, or nearest star system, Alpha Centauri. That's about 4 light years away. And we try to develop the technology that will allow us to reach that star within our lifetime. And it means sending a probe at a fraction of the speed of light, using light to propel it, using a laser beam to push on a sail. And that's what allowed me to think about the possibility of a light sail for Oumuamua. But at any event, we are contemplating sending light sails to the nearest star system. And my hope is that by the time we exit the solar system, we would realize that there is a lot of traffic out there, and in fact we will get a message: welcome to the Interstellar Club, so to speak.
Sure.
Because at that point we would mature from being a civilization that is restricted to living on one planet, the Earth.
Yeah.
To a civilization,
and a civilization who condemns people who think that we could do these things that you're talking about.
Right. That's another sign of not being mature. I have 2 daughters, and when they were very young, they tended to think that the world centers on them. And then as they matured, they realized, oh no, actually there are other people out there, and I'm not at the center of the world, and so on. And in a way, if you think about it, our civilization behaved exactly the same way. We thought that we are at the center of the action, and eventually, if we find evidence for life out there, we would realize, we would mature. We would become a mature civilization that realizes that we are not the center of the action, that we have a lot to learn from, and that we should be modest, and explore space. That's a fantastic opportunity. Why always look down?
Right.
Every now and then look up and see how big space is out there. and how much more opportunity it offers to us than sticking to this piece of rock that was left out from the debris that made the sun, that we happen to live on and we're born on. Why limit ourselves to this piece of rock? It's obviously we call it home, but it offers a lot of risks together for the distant future, and we should contemplate going elsewhere.
Yeah, absolutely. Now you talked about this light sail that the Starshot Initiative is working to create. You said that potentially that could happen within our lifetime. That it would be created within our lifetime, or that would reach there. Because how much time are we talking here that it would take for it to go from here to the nearest star?
So the project was defined such that we will deliver a probe to the next star within our lifetime, meaning that that's the journey time.
Sure.
But that depends on whether we are able to develop the necessary technology, and that could take more than that. But basically what happened was the funder of this project, Yuri Milner, came to my office from where I'm speaking right now, and asked me if I'm willing to look into the possibility of designing such a project. And after 6 months of discussions with my students and postdocs, we arrived at the conclusion that there is only one method to do that, which is pushing a sail with light. That's the only way to reach a fraction of the speed of light. All other methods are not capable of doing that. But I told Yuri that, it's just like getting married. If you have a problem finding a person, you just need one solution to this problem. You just need to find one solution. It's enough.
Right.
And fortunately, there is one solution, which is pushing a sail with light. And that's the solution that we converged on. And right now we have solicited proposals and decided to allocate grants to about a dozen experimental teams that are exploring the laser technology, and another dozen of experimental teams that explore the sail technology. You need the sail to be made of material that is highly reflective, very sturdy, and lightweight. And you need to design the shape of it such that it will ride in a stable fashion on the laser beam. And there are lots of challenges to this technology, and we are just starting the journey of exploring. And so I cannot tell you how quickly we will build the final system.
Sure.
Because that depends on what we find as we do the experimental work. But once the system is built, the hope is that when we send out a probe, it will take it less than our lifetime to reach the nearest star, of all the 20 years or so, if it moves at a fifth of the speed of light, for example.
Sure. Fascinating stuff, and really cool to look forward to. Hopefully, I'm hoping that it comes up in my lifetime, and the people that listen to the show know that I like to dig into some crazy theories that we're going to get into in the bonus content, because I want to pick your brain on some outlandish things that I like to look into. But is there anything else on Oumuamua that you think we should touch on before we wrap up here?
Well, just one thing that we don't know if it's natural or artificial in origin, but the one problem that you face, if you assume that it's one object out of a population of objects on random trajectories, is that each star in the Milky Way galaxy had to produce 10 to the power 15 such objects in order to account for Oumuamua as being one of them that passes so close to the Earth during the time that the Pan-STAR survey operated. So that's a huge number. That's 1,000 trillion. That's much more, as I mentioned, much more than we expected from the solar system to produce during its lifetime. If you think that it's artificial, then it's very difficult to produce so many of them, because you basically, if you have one civilization per star, even if that civilization continues to launch these systems throughout the age of the universe, the entire age of the universe, you need to launch one system per minute or every few minutes. It's really a huge task to produce so many of them in the Milky Way galaxy. And an alternative to that, you can save on the number of systems if they are not on random trajectories. If, for example, such a probe was on a special plunging orbit that was designed to dive into the habitable region of the solar system. Then you need very few of these objects because they are only going on a very special orbit that goes into the inner region of the solar system where life may exist. That's the so-called habitable zone. And you cut down the number of necessary objects by a factor of 30 million if you do that. Mm-hmm. And so it would seem to me that, if it is artificial in origin, then it probably was on a special trajectory. But we don't know. And we should check for additional objects, additional visitors,
right,
to the solar system, sort of like arranging another dinner party and waiting for who comes in through the door. And hopefully there would be another peculiar one, another weird object coming along, and then we will be able to look very closely at it. But I should say, well, if the second one is as unusual as Oumuamua was, then that would make it a clear-cut unusual population, and we will learn something new irrespective. Even if it's natural, it's not the kind of object you would expect from a solar system type nursery. There must be some very special places that produce these objects at a larger abundance and with properties that are so different than what we expected. So we will learn something new no matter what, whether it's artificial or natural. If we don't find another one, it would make it extremely strange and unusual. And then we will have to think about chasing this one down.
Yeah, absolutely. Well, Doctor, it's all fascinating stuff. I really enjoy it. And I really think the world needs more like open-minded scientists, more people who are willing to show their humanity and say, hey, I could be wrong, but this is the only solution that I can see to this conundrum that we found ourselves in with this discovery. So I really applaud you for putting yourself out there. Can you go ahead and tell everybody where they can find out more information about you, all the work that you do, and everything that you got going on?
Yes, I have a website that one can get to by putting my name in Google, Avi Loeb, A-V-I-L-O-E-B. And the first entry is my webpage, my personal webpage, where you would see videos and news items and the papers that I wrote, and basically any information that, or in fact, I should mention that I wrote more than a dozen Scientific American articles over the past few months, and some of them relate to Oumuamua. So if you go to Scientific American and search for my name, Abraham Loeb or Avi Loeb, you will see all of them, and I encourage you to have a look. Each of them is about a couple of pages, 2-3 pages, and I wrote it in a way that I hope is understandable.
Mm-hmm. Fantastic. And again, I applaud you. Thank you so much for being here. I'm sure with everything that you've got going on, it's a bit of a time crunch. So I want to let you go, and I want to get into a little bit of bonus content, like I said, and pick your brain on some more outlandish things that my listeners might appreciate more than some of your colleagues. But thank you so much for your time. I really appreciate it. I look forward to having you on again in the future. You're always welcome here.
My pleasure. Thank you.
Hey guys, thanks for sticking around to the end. I hope you enjoyed my conversation with Dr. Loeb as much as I did. And if you couldn't tell, I really, really enjoyed it. Like I said at the beginning of the show, I mean, he and I differ on some things. I've got this crazy conspiracy brain that likes digging into things like flat Earth and climate change and the moon landing. And I'm guessing him not so much. But still, he's able to speak to somebody like me and do so in a very respectful and humble manner. And I think it's just a beautiful thing. That's what this show is all about. He is basically the epitome of what I want this show to be about. We're all humans, as I always say. We're all trying to figure stuff out together. And if we come across something that we don't understand, then we have to explore other ideas of thought. Think that maybe we're wrong about some things. I think it's great. I think that what Avi is doing is great. And like I said at the beginning of the show, if you want the bonus episode where I did bring up all the crazy conspiracy theory things, you can get that content in the Downers Club by going to patreon.com/thesystemIsDown. That is a place where you can give a little bit back to the show and help us getting bigger and better, getting better guests and growing, expanding our numbers, looking more crisp and clean and beautiful and sounding better every single week. Every dime that you give goes right back into making this show better for you. And in return, you get multiple bonus audio and video episodes of this show every single week. I mean, what's not to love about that? So patreon.com/The System Is Down. And you can sign up for as little as a cup of coffee a month. Go check it out. I think you're going to enjoy it. Or you can just peace out and go on your merry way. And you're out almost nothing. But yeah, go check it out. Patreon.com/The System Is Down. Also, if you're not already a member of our forum, I keep forgetting to bring this up lately. Somebody reminded me, hey, you need to be talking about the forum more. We need to get the forum building. We need to get more people in there that have different thoughts, so we can have these conversations, and it's not just your typical Facebook echo chamber. So you can go over to facebook.com and just type in The System Is Down forum, and you'll find it there. You'll have to ask to join. It's a closed forum, but if you look like a real human, I'll let you in. Or you can go to tsidpod.com/forum and join it that way. But it's a great place to have these conversations, and people are just nice and kind and respectful to each other in there. So if you want to push your thoughts a little bit, if you want to push somebody else's thoughts and not get called a shill or a douchebag, System Is Down forum. Go check it out. All right. Now, as of 2019, I'm currently doing my very best to expand onto a bunch of different platforms. So please go look around for The System Is Down on any platforms that you're on. Very soon we will be on different things like I'm going to bump up the BitChute stuff. I'm going to probably jump on Minds and Gab and all those things. So keep an eye out for The System Is Down. Tell some people to go follow, because I want to expand this, boost our numbers, and make this a better experience for everyone involved. So until then, I'll let you know when all that stuff goes out. You can look around right now. It might be out by now, but it might not be. Not sure yet. Not sure. Things are unfolding rapidly, and it's going to be a good year. I guarantee it. But until then, at least go over to all the platforms that you already know and you're already familiar with, like Facebook, Twitter, YouTube, iTunes. Give all the likes, shares, subscribes, downloads, everything that helps keep this show progressing. Let's do this together, and we'll make 2019 a freaking awesome year. I think it's going to be good. It's going to be good. I've got some plans and some high hopes that I think are very, very reachable. Setting some goals. I'm also working on some personal stuff and some mental stuff, and I'll probably talk about that more as the show unfolds, and hopefully I seem a little bit more mentally healthy as the show progresses. But good things to come in 2019. Thank you guys so much for your support and your listenership, sharing the show. Please just share the show with one or two people this week. I appreciate it very, very much. But yeah, I appreciate you guys just listening, even for free, and enjoying it. It means a lot to me that you guys are getting something out of this, and I hope to continue to make it bigger and better for you. So thanks for tuning in today, and if you'll have me, of course, I will be here first thing next Monday morning with some more uncomfortable content for your little ear canals. Until then, ladies and gentlemen and everything in between, question everything and stay uncomfortable. Thanks. This has been a Goulash Media production. goulashmedia.net.
This concludes our broadcast day. Click.